What specific problem does your proposed method aim to solve in the context of literature review generation using large language models?
Our proposed method aims to solve the problem of generating high-quality literature reviews by leveraging intermediate plans in the context of literature review generation using large language models, LLMs. Traditional zero-shot generation methods, as highlighted in the Multi-X Science dataset, often result in lower quality outputs due to their lack of structured content planning. By introducing a plan-based prompting technique, we enhance the generation process, allowing the model to first create a sentence plan that guides the final summary output. This approach not only improves the coherence and relevance of the generated literature reviews, but also addresses the issue of hallucination, where LLMs may produce non-existent citations. Our empirical evidence demonstrates that this novel strategy significantly outperforms vanilla zero-shot generation methods, thereby providing a more effective tool for researchers drafting literature reviews.
How does the proposed plan-based prompting technique work? Can you illustrate the process step by step, detailing how the model generates an intermediate plan before creating the final summary?
The proposed plan-based prompting technique involves a two-step process to enhance the quality of literature review generation. First, the model generates a sentence plan as an intermediary step, which outlines the structure and content of the final summary. This plan is then used to condition the model, allowing it to output the final summary autoregressively based on the predefined structure. Alternatively, humans can provide a ground truth plan, which facilitates an iterative setting that enhances controllability over the generated text, reducing the likelihood of extraneous content. This method contrasts with traditional zero-shot generation by incorporating structured planning, which empirically improves the quality of the generated literature reviews compared to vanilla approaches.
Can you provide a simple example to illustrate how the intermediate planning works in your method, such as a short abstract, and how the generated plan would guide the summarization?
In our method, the intermediate planning involves generating a structured sentence plan before producing the final summary. For example, consider an abstract discussing the impact of machine learning on healthcare. The generated plan might outline key points such as 1. Introduction to machine learning in healthcare. 2. Benefits observed. 3. Challenges faced. 4. Future directions. This plan serves as a guide for the LLM to construct the summary in a coherent manner, ensuring that each point is addressed systematically. By conditioning the generation on this plan, the model can produce a more organized and relevant literature review, as evidenced by our empirical findings that show improved quality over traditional zero-shot generation methods.
What empirical results or metrics did you observe that demonstrate the effectiveness of your plan-based approach over the vanilla zero-shot generation method?
The empirical results from our study indicate that the plan-based approach significantly outperforms the vanilla zero-shot generation method in generating literature reviews. Specifically, we observed that the use of intermediate plans led to improved quality in the generated outputs, as evidenced by higher precision and normalized recall metrics. In our ablation study, we found that removing the verification step in our debate re-ranking strategy resulted in a significant drop in both precision and normalized recall, with p-values of 4.74 and 1.9 times 10 to the minus 6 respectively. This suggests that the plan-based prompting not only enhances the generation process, but also ensures more accurate rankings of candidate papers. Overall, our findings demonstrate that incorporating intermediate plans provides a more structured and effective approach to literature review generation compared to traditional zero-shot methods.
How did you validate or test your proposed method, particularly with respect to the datasets used and the metrics for performance? What was the significance of using a new test corpus consisting of recent archive papers?
We validated our proposed method by employing a new test corpus consisting of recent archive papers to avoid test set contamination, ensuring that our evaluation was based on up-to-date and relevant data. This corpus allowed us to rigorously assess the performance of our literature review generation strategy against a contemporary dataset, which is crucial for accurately reflecting the current state of scientific discourse. We measured performance using metrics such as precision and normalized recall, which quantify the accuracy of retrieved papers in relation to the ground truth. Our empirical study demonstrated that the use of intermediate plans significantly improved the quality of generated literature reviews compared to vanilla zero-shot generation, as evidenced by the significant drop in precision and normalized recall when verification steps were removed. This validation process underscores the effectiveness of our method in generating relevant and accurate literature reviews in a challenging retrieval context.
What limitations did you encounter with your proposed method, particularly in the retrieval process and the quality of generated literature reviews based on your findings?
In our proposed method, we encountered several limitations during the retrieval process and in the quality of generated literature reviews. Firstly, the retrieval of related work yielded a low coverage of just under 7% of ground truth papers, primarily due to the inherent challenges of capturing the diverse styles and methods authors use in literature reviews. Additionally, our retrieval process was constrained to generating search keywords solely from the abstract, which limited the contextual richness that could enhance retrieval rates. Furthermore, while our plan-based generation strategy improved the quality of literature reviews, we found that the use of GPT-4 for re-ranking was brittle, producing incomplete lists 41% of the time and occasionally including repeated or nonsensical values. Lastly, the ablation study indicated that removing the attribution verification step significantly decreased precision and normalized recall, highlighting the importance of accurate citation verification in maintaining the quality of generated outputs.